Okay, so we've defined our function, and now we are going to loop over all of these files and apply that function to each files and get the gradient. In other words, the rate at which weight is put on by each of those elements. I'm going to store all of that information in a vector, which I'm just going to define very quickly, called gradient value or grad vals. And I'm just going to define an empty vector like that, just like that. Control and enter on that. And now I'm going to sort of showcase to you another huge staple of coding, which is a loop. And in this instance, I'm going to use a for loop. There are lots of different types of for loops. I really only ever use for loops, actually. And we're going to define it like this, right? So we're going to use a for loop. This is how you write it. For, I'm going to call a variable called file in files. Now, this one is important because this is related to the variable I've already defined above called file. So that's my entire list of file names, and I've gone straight into Python there. This is how you do it in R. And what this loop is going to do is it's going to look at my entire list of files, and then it's going to say, right, for this temporary variable file in files, do this. So it's going to look at this one first, and then whatever I type in here, it's going to do, and then it's going to go around to the next file, and then the next one, and the next one, until it gets to the very end of the list, okay? Now, for each of those files, I want to extract that gradient using the function above and slam it into my grad vals vector here, okay? So it's basically going to store all of that extraction as it loops. So I'm going to call, I'm going to define a temporary variable called file gradient, file grad. And to get that value, I'm going to use the function above called get gradient. And I'm going to use my directory variable I've defined up here. And this time I'm going to call file as the file name, okay? And that is this temporary variable again here, which is going to change dynamically as we loop through this for loop, okay? Okay, so that should give a gradient into this variable for any of these given files as we loop through. Now I want to add that value to my currently empty vector as we go along. So to do that, I just define the vector again, and I call it self, and then add that file grad. Right, there you go. Okay, and that is it. Just those two lines, I'm pretty sure. I'm going to run Control and Enter on that. And I have to, every time you run Control and Enter on a loop or a function, you have to do it on the first line of that, otherwise you'll get an error probably. Let me see if I can create an error. There you go. Okay, so you have to, every time you change something in a function or a loop, you have to run the first line Control and Enter again. Okay? Right, so you can see now actually that I've got this grad vals vector which has 2,000 variables in, right? That's because I've run it twice. I'm gonna null that again and run that, and there you go. It's got 1,000 values in. So that is 1,000 values corresponding to each gradient associated with each of those files. So I can print that out. Let's just grad vals and see what that looks like. There you go. They are all those gradients from each of those files. How do I find out which is the maximum value? You might guess this one. It's just max grad vals. So the maximum gradient value was 36.86572. Okay. Now that's nice. It's good to know that, but that doesn't really help us because we don't know what value that corresponds to in my list, which means I don't know which elephant it belongs to at the moment, right? So basically I want to get the index of that value from my vector. So what position in my vector does that maximum value correspond to? That's easy to do. It's a function called which max grad vals. If you run that, it's telling you that it's the 936th value in my vector. Okay, so it's pretty close to the end of this list, so it's going to be down here somewhere. That still doesn't help me because these numbers are not labeled from 1 to 1,000. They've actually got sort of relatively random digit codes, the 6-digit codes. So how do I find the file that corresponds to? Well, I've already defined these files in order in this variable here. So I'm just going to call my variable files. Oh, not down here, over here. And then I'm going to spit out the, enter the index which.max grad vals for it to tell me which file name is the correct one. And there you go, it's elephant 963251. 962, there he is. Oh, it happens to be right there. There you go. Have a look at that file. That is the elephant we were interested in. 963251. So there you go. We've done it. Right, so as an extension, I challenge you to not only extract the gradient from each of those files, but to plot and save a scatter plot for each of them as well, with a trend line on and with an equation of line on the graph. Okay, you can do that as well.